Price elasticity of demand. Price, price elasticity of demand is a measurement of the change in the composition of a product in relation to a change in its price. Expressed mathematically, it is price elasticity of demand is equal to percentage change in quantity demanded divided by percentage change in price. Economists use price elasticity to understand how supply and demand for a product change when its price changes. Like demand, supply also has an elasticity known as price elasticity of supply. Price elasticity of supply refers to the relationship between change in supply and change in price. It's calculated by dividing the percentage of change in quantity supplied by the percentage change in price. Together, the two elasticities combine to determine what goods are produced at what price. What is elasticity? Elasticity is a measure of a variable's sensitivity to a change in other variables or a single variable. Most commonly, this sensitivity is the change in quantity demanded relative to changes in other factors such as price. In business and economics, price elasticity refers to the degree to which individuals, consumers, or producers change their demand or the amount supplied in response to price or income changes. It is predominantly used to assess the change in consumer demand as a result of a change in a good or service's price. Elasticity is an economic measure of how sensitive one economic factor is to changes in another. For example, changes in supply or demand to the change in price or changes in demand to changes in income. If demand for a good or service is relatively static, even when the price changes, demand is said to be inelastic and its coefficient of elasticity is less than 1.0. Examples of elastic goods include clothing or electronics, while inelastic goods are items like food and prescription drugs. Price elasticity of demand. Economists have found that the prices of some goods are very inelastic. That is, a reduction in price does not increase demand much, and an increase in price does not hurt demand either. For example, gasoline has little price elasticity of demand. Drivers will continue to buy as much as they have to, as will airlines, the trucking industry, and nearly every other buyer. Other goods are much more elastic, so price changes for these goods cause substantial changes in their demand or their supply. Federal Reserve Bank of St. Louis, Elasticity of Demand, the Economic Lowdown podcast series. If the quantity demanded of a product changes greatly in response to changes in its price, it is elastic. That is, the demand point for the product is stretched far from its prior point. If the quantity purchased shows a small change after a change in its price, it is inelastic. The quantity didn't stretch much from its prior. Factors that affect price elasticity of demand. Availability of substitutes. The more easily a shopper can substitute one product for another, the more the price will fall. For example, in a world in which people like coffee and tea equally have the price of coffee goes up. People will have no problem switching to tea and the demand for the coffee will fall. This is because coffee and tea are considered good substitutes for each other. Urgency. The more discretionary purchase is, the more its quantity of demand will fall in response to price increases. That is, the product demanded has greater elasticity. So, you are considering buying a new washing machine, but the current one is still worse. It's just old and outdated. If the price of a new washing machine goes up, you are likely to forego that immediate purchase and wait until prices go down or the current machine breaks down. The less discretionary a product is, the less its quantity demanded will fall. Inelastic examples include luxury items that people buy for their brand names. Addictive products are quite inelastic, as are required add-on products such as inkjet printer cartridges. Duration of price change. The length of time that the price changes last also matters. Demand response to price fluctuations is different for a one-day sale than for a price change that lasts for a season or a year. Clarity of time sensitivity is vital to understanding the price elasticity of demand and for comparing it with different products. Consumers may accept a seasonal price fluctuations rather than change their habits. Types of price elasticity of demand. Price elasticity of demand can be categorized according to the number calculated by dividing the percentage change in quantity demanded by the percentage change in price. These categories include the following. Types of price elasticity of demand. If the percentage change in quantity demanded divided by the percentage change in price equals, it is known as, which means infinity, perfectly elastic, changes in price results in demand declining to zero. If the percentage change in quantity demanded divided by the percentage change in price equals or greater than 1, it is known as elastic, which means changes in price yields a significant change in demand. If the percentage change in quantity demanded divided by the percentage change in price equals to 1, it is unitary, which means changes in price yields equivalent changes in demand. If the percentage change in quantity demanded divided by percentage change in price equals or less than 1, it is said to be inelastic, which means changes in price yields an insignificant change in demand. If the percentage change in quantity demanded divided by the percentage change in price equals is 0, it is said to be perfectly inelastic, which means changes in price yields no change in demand. If the percentage change in quantity demanded divided by the percentage change in price equals to 0, which is said to be perfectly inelastic, changes in price yields no change in demand. Examples of price elasticity of demand. As a rule of thumb, if the quantity of a product demanded or purchased changes more than the price changes, then the product is considered to be elastic. For example, the price goes up by 5%, but the demand falls by 10%. If the change in quantity purchased is the same as the price change, say 10% divided by 10% equal to 1, then the product is said to have unit or unitary price elasticity. Finally, if the quantity purchased changes less than the price, say minus 5%, demanded for a plus 10% change in price, then the product is deemed inelastic. To calculate the elasticity of demand, consider this example. Suppose that the price of apples falls by 6% from $1.99 a bushel to $1.87 a bushel. In response, grocery shoppers increase their apple purchase by 20%. The elasticity of apples is thus 0.20 divided by 0.06, which means 3.33. The demand for apples is quite. What is price elasticity of demand? Price elasticity of demand is the ratio of the percentage change in quantity demanded of a product to the percentage change in price. Economists employ it to understand how supply and demand change when a product's price changes. What makes a product elastic? If a price change for a product causes a substantial change in either its supply or its demand, it is considered elastic. Generally, it means that there are acceptable substitutes for the product. For example, examples would be cookies, luxury automobiles, and what makes a product inelastic? If a price change for a product does not lead to much, if any change in its supply or demand, it is considered inelastic. Generally, it means that the product is considered to be a necessity or a luxury item for addictive constituents. Examples would be gasoline, milk, and iPhone. Cross-elasticity of demand. The cross-elasticity of demand is an economic concept that measures the responsiveness in the quantity demanded of one good when the price for another good changes. Also called cross-elasticity of demand, this measurement is calculated by taking the percentage change in the quantity demanded of one good and dividing it by the percentage change in the price of the other good. The cross-elasticity of demand is an economic concept that measures the responsiveness in the quantity demanded of one good when the price for another good changes. The cross-elasticity of demand for substitute goods is always positive because the demand for one good increases when the price for the substitute goods increases. Alternatively, the cross-elasticity of demand for complementary goods is negative. In economics, the elasticity of demand refers to how sensitive the demand for a good is to changes in other economic variables such as price or consumer substitute goods. The cross-elasticity of demand for substitute goods is always positive because the demand for one good increases when the price for the substitute goods increases. For example, if the price of coffee increases, the quantity demanded for tea, a substitute beverage, increases as consumers switch to a less expensive yet substantial alternative. This is reflected in the cross elasticity of demand formula As both the numerator, percentage change in the demand of tea, and denominator, the price of coffee, show positive increases. Items with a coefficient of 0 are unrelated items and are good independent of each other. Items may be weak substitutes in which the two products have a positive but low cross-elasticity of demand. This is often the case for different product substitutes, such as tea versus coffee. Items that are strong substitutes have a higher cross-elasticity of demand. Consider different brands of tea. A price increase in one company's green tea has a higher impact on other companies' green tea demand. Complementary goods. Alternatively, the cross-elasticity of demand for complementary goods is negative. As the price for one item increases, an item closely associated with that item and necessary for its consumption decreases because the demand for the main good has also dropped. For example, if the price of coffee increases, the quantity demanded for coffee stir sticks drop as consumers are drinking less coffee and need to purchase fewer sticks. In the formula, the numerator, quantity demanded of a stir sticks, is negative and the denominator, the price of coffee, is positive. This results in a negative cross-elasticity. Toothpaste is an example of a substitute good. If the price of one brand of toothpaste increases, the demand for a competitor brand of toothpaste increases. Methods of measuring price elasticity of demand. Basically, there are four ways by which we can calculate the price elasticity of demand, and these are percentage method, total outlay method, point method, and arc method. Percentage method, price elasticity method. The percentage method is one of the widely used methods for calculating demand price elasticities, where price elasticity is calculated in terms of the rate of the percentage change in the quantity requested to the percentage change in price. The price elasticity of demand can, according to this approach, be mathematically expressed as PED is equal to percentage change in quantity demanded divided by percentage change in price, where change in quantity is equal to new quantity Q2 minus initial quantity Q1, initial quantity Q1 into 100, change in quantity demanded is equal to new quantity Q2 minus initial quantity Q1 initial quantity multiplied by 100. Change in price is equal to new price P2 minus initial price P1, initial price P1 multiplied by 100. Change in price is equal to new price P2 minus initial price P1, initial price P1 multiplied by 100. Therefore, PED is equal to delta Q delta P multiplied by P1 Q1. For example, when the price of a commodity was rupees 10 per unit, the market demand for that commodity was 50 units a day. When the price of the product dropped to rupees 8, demand increased to 60 units. The price elasticity of demand can here be calculated as PED is equal to percentage change in quantity demanded divided by percentage change in price, where in comparison to supply price elasticity, demand price elasticity is often a negative number since the quantity requested and the product share price are inversely related. This implies that the higher the price, the lower the demand, and the lower the price, the greater the product demand. Total outlay method. Professor Alfred Marshall developed the total outlay method, also known as the overall cost method of calculating price demand elasticity. The price elasticity of demand can, according to this approach, be calculated by comparing the total expenditure on the commodity before and after the price adjustment. We can get one of three results when comparing the expenditure. They are the request elasticity would be greater than the unity of EP is greater than 1. If total expenditure rises with a decrease in price and it decreases with a rise in price, the value of the PED is greater than 1. Here, price rises and overall spending or outlay shift in the opposite direction. The elasticity of demand will be equal to unity, EP is equal to 1. If, in response to a rise in the price of the commodity, the overall expenditure on the commodity remains unchanged, the value of the PED would be equal to 1. The elasticity of demand will be less than unity, EP is smaller than. The value of PED would be less than 1 if total spending decreases with a decline in price and rises with a rise in price. Here, commodity prices and overall spending are going in the same direction. When the information from the above table is plotted in the graph, we get a graph like the one shown below. On the x-axis, gross outlay or cost is calculated in the graph, while the price on the y-axis is measured. The transfer from point A to point B demonstrates elastic demand in the figure, as we can see that overall spending has risen with price decreases. As total expenditure has remained unchanged with the change in price, the shift from point B to point C demonstrates unitary elastic demand. Likewise, as overall expenditure as well as price has increased, the shift from point C to point D indicates inelastic demand. Price elasticity of a linear demand curve. If the demand curve is linear in nature, the PED is determined simply by applying the above expression. That is, PED is equal to lower segment of the demand curve, upper segment of the demand. Mn is the linear demand curve in the figure and P is the midpoint of the curve. Therefore, at point P, PED is equal to lower segment of the demand, upper curve segment of the demand curve. Elasticity on a nonlinear demand curve. If the demand curve is nonlinear or convex in nature, then at the point where the PED is to be determined, a tangent line is drawn. Then again, PED is measured as PED is equal to lower segment of the demand curve, upper segment of the demand curve. Point method. The point method of measuring price elasticity of demand was also devised by Professor Alfred Marshall. This method is used to measure the price elasticity of demand at any given point in the curve. According to this method, elasticity of demand will be different on each point of a demand curve. Thus, this method is applied when there is a small change in price and quantity demanded of the commodity. According to this method, price elasticity of demand is mathematically expressed as lower segment of the demand curve divided by upper segment of the demand. However, the method of calculating PED depends upon the nature of the demand curve. These methods are explained below. If the demand curve is linear nature, PED is simply calculated by applying the expression given above. That is, in the figure, Mn is the linear demand curve and P is the midpoint of the curve. Therefore, at point P, PED is equal to lower segment of the demand curve divided by upper segment of the demand curve is equal to Pn divided by Pm is equal to. In the same way, at point A, PED is equal to An divided by Am, which is greater than 1. At point B, PED is equal to Bn divided by Bm, which is smaller than 1. At point M, PED is equal to Mn divided by 0, which is infinite. At point N, PED is equal to 0 by Mn, which is price elasticity of a nonlinear demand curve. If the demand curve is of nonlinear or convex nature, then a tangent line is drawn at the point of which the PED is to be measured. Then PED is once again calculated as PED is equal to lower segment of the demand curve divided by upper segment of the. In the given figure, DD is a non-linear demand curve. If P is the point where we want to measure price elasticity, then we have to first draw a tangent through that point. Thus, tangent Mn has been drawn through point P. Now, PED can be measured as PED is equal to lower segment divided by upper segment is equal to PM divided by arc method. Any 2 points on a demand curve make an arc, and the coefficient of price elasticity of demand of an arc is known as arc elasticity of demand. This method is used to find out price elasticity of demand over a certain range of price and quantity. Thus, this method is applied while calculating PED when price or quantity demanded of the commodity is highly changed. In the figure, we can see that AB is an arc on the demand curve DD and point C is a midpoint on AB. If we followed point method to measure PED at points A and B in the curve DD, we get different coefficients as a result of using different bases. To avoid this discrepancy, elasticity is measured by taking mean values of price and quantity demanded in the arc method. The average of price and quantity demanded is calculated as average price is equal to P1 plus P2 divided by 2 and average quantity demanded is equal to Q1 plus Q2 divided by 2. Once the average value of the price and quantity demanded are determined, PED at point C can be calculated by applying following formula. PED is equal to change in quantity demanded divided by average quantity demanded divided by change in price upon average price, which is delta Q divided by Q1 plus Q2 divided by 2, further divided by delta P divided by P1 plus P2 divided by 2, that is delta Q upon delta P multiplied by P1 plus P2 and Q1 plus Q2, which is Q2 minus Q1 divided by P2 minus P1 multiplied by P1 plus P2 divided by Q1 plus Q2, where delta Q is equal to change in quantity demanded Q2 minus Q1, Q1 initial quantity demanded, Q2 is equal to new quantity demanded, delta P change in price, that is P2 minus P1. P1 is the new price and P2 is the initial price.